Don't forget to subscribe and share. Thank you.
All right, thank you so much for joining us again. I'm so excited you are here again for us to learn. Now we are come to look at the cosecant function inverse. So now remember from the previous video, we saw that when I take the derivative of secant inverse of x, this is 1 divided by u square root of u squared minus 1. Okay, let me use x. This is what you are going to get. So this is just the minus of this. So sine goes with cos, tan goes with cotangent, and secant goes with cosecant. So just learn 3 of them. You can learn sine inverse, tangent inverse, and secant inverse. And you will see that the rest are all just the inverse. What you need to know is you need to know the one that goes with them. And you see that tangent, you shouldn't forget that tangent is like cotangent. So tangent and cotangent, they are all having tangent in it. And secant and cosecant, so that if you forget that cos is going with, and even we have sine and cosine. Great. So we have gotten the technique right away from here. So let's just figure out what we are going to do here. So as we saw from this here, this one here, this is just going to give us, if I want to differentiate y with respect to x, which is d over dx, cosecant inverse of x, this is going to give us minus 1 divided by x square root of x squared minus 1. Beautiful. So let's put our formula down here. D dx of cosecant inverse of x is minus 1 divided by x square root of x squared minus 1. So this is what we are going to do, or what we are going to use to solve our examples. Let's do the proof quick and then done. So right now, I'm sure you can do the proof. Or let me leave, I think we've done all the proofs, right? So let me leave this proof for you. Please, when you do this one, I want you to post your answer in Merbs Connect community, how you're able to prove that this is equal to what we have here. I really want to see that. So prove it and leave your answer in the Merbs Connect community. So let me just give you this for you to try. Now let's get to this. Suppose we have this. So now we want to write the generalized aspect of this. So this is this inverse of x. Okay, this is u now. So this is going to be minus 1 divided by u squared minus 1 times u prime. So that is all. Right. Don't forget to do the proof and post your answer in the Merbs Connect community. So find derivative of this, another product rule here. Let's enjoy it. X of squared cos inverse of x. So product rule, we need to have our a. Let's choose a to be x squared. A prime will be equal to 2x. And let's choose b to be equal to cos inverse of x. So b prime will be equal to, so from the formula that we just learned, b prime is going to be minus 1 divided by x square root of x squared minus 1. Beautiful. So let's just use the product rule quick here. So multiply this by this and this by that. So a b prime plus b a prime. A is x squared, b prime is minus 1 over x square root of x squared minus 1, plus b is cosec inverse of x, or the cosecant of x, times a prime is 2x. Simplify this. One of the x will cancel one of the x here. So this is going to give us minus x divided by square root of x squared minus 1. Then this is plus 2x cosecant of x. Beautiful, beautiful. Let's run through quick. And then now, the next, I will tell you the next, what we are going to do in our next video. Now let's differentiate this one to d over the x. This is differentiating with respect to x, secant of cos of x. So this is the change rule. So we need to use the change rule that we learned, which is a general rule. So cosec inverse of u is 1 divided by u. Okay, that should be minus, yes. Minus 1 times u prime. So this is what we need. So we can see that when you compare this to this, our u is cos of x. So u is cos of x. U prime will be just minus this. So let's do substitution here. So this is going to be minus 1 divided by, so u here is cos. So we have cos of x, then square root of u squared, which is cos of x all squared, minus 1 times u prime, which is minus sine of x. So let me just bring it down small and try to simplify what we have here. So minus is going to be positive. So this is going to be sine of x divided by cos of x square root of, this is the same as cos x squared, cos squared of x minus 1, and this is what you're going to get. So it's very simple to deal with it. It's just short video here. Let's finish it up. Another product rule here, let's pick our a to be equal to sine inverse of x. A prime will be equal to, let me put a prime here. A prime will be equal to cos of x. B is equal to cosec inverse of x, and b prime will be equal to 1 divided by x square root of x squared minus 1. So this is very much easier than I thought. So this is sine of x cotangent inverse of x. So product rule a b prime plus b a prime. So let's just do substitution. A is sine of x, b prime is 1 divided by x square root of x squared minus 1, and b is cosecant inverse of x times a prime is cos of x. So when I simplify this, I have sine of x divided by x square root of x squared minus 1, then plus cos of x, and then cosecant inverse of x. Also very simple here. So let's do the last question, and then we are done going through all the trig inverse functions, and then we see what is up for us to do in the next video. So let's go through quick. D over the x, this is going to be d over the x cos inverse of square root of x plus 1. Yes, and this is going to give us, okay, so let's use the general one. So let me just write it somewhere here. We know that x cosecant inverse of u is 1 minus 1 divided by u squared minus 1 times u prime. What is u here? Okay, our u is equal to square root of x plus 1, as we can see from the parentheses here. Now this is the same as x plus 1 to the power 1 over 2. So u prime is going to be, using the power rule, half drops down, then we subtract 1 from this, and we have minus 1 over 2 times, using the change rule, we need to differentiate what is inside the parentheses now, and that one is going to give us 1. So this is going to give us 1 over 2 times 1 over x plus 1 to the power 1 over 2. We can simplify this to have 1 divided by 2 square root of x plus 1. So we have u prime. So we are just going to use this formula here. We substitute u and then u prime for this. So this is minus 1 divided by, we have a u here, what is this? So this is going to be, let me put it inside parentheses, x plus 1, then square root of u squared. So square root of x plus 1 squared, which is our u minus 1, times u prime, which is 1 divided by 2 square root of x plus 1. Beautiful. Let's try and see if we can do some small simplification here. So square root of x plus 1 in parentheses. When I take the square roots and I square it, square will cancel the square root, so it will be left with x plus 1 minus 1. Great. Times 1 over 2 square root of x plus 1. Let's do more simplification here. I think I'm seeing something beautiful at the end of the simplification. So minus, now remember that when I multiply square root of a times square root of a is just a, because this is like I have 1 to the power half, 1 a to the power 1 over 2 times a to the power 1 over 2. Using indices, this is the same as a 1 over 2 plus 1 over 2, and 1 over 2 plus 1 over 2 is 1, so it's just going to be that. So it means that when I multiply square root of x plus 1 and square root of x plus 1, it's just going to give me x plus 1, because we just look at what is here. It just gives us the a. So this is going to give us 1. This is going to give us minus 1 divided by, so this times this is going to give us just x plus 1. So I'm just going to have 2x plus 1. So I have my 2 here, and I multiply this by this, and I have x plus 1. And this one, this is just going to go away, so I'm just going to have square root of x. So if I want to write this one, I just write it 2 square root of x, x plus 1. That will be the final result here. So this will be your trial question for you to try. Try and leave your answer in the comment section. And as I said, if you think your answer is so complicated and you want to show all your solution to, you can take a picture of it, and then you post it in the Merbs Connect community. Now we are done with looking at the inverse functions, right, of the trig functions. So in the next video, we are going to look at using the inverse function theorem to find derivative. So we started the video after we looked at inverse of a function. We looked at using the inverse function theorem to find the inverse derivative. Great. Now you see that everything that we are doing here, we can also use the inverse theorem to do that, taking the derivative, right? We can also do the same thing. I will compare some examples, advanced examples, and then we can do, we can just go through successfully. So now we are going to look at the next video. We are going to look at using the inverse function theorem to find derivatives, and then we'll look at some examples and we'll continue from there. So see you in the next video.